Hi, so today I'm gonna teach you about derivatives and some of its application to real-life problems. But first, you have to know what is a derivative. So, a derivative is a is the rate of change of a function given a specific value of x. So, so what are the various applications of derivatives? So, derivatives can actually be used in many fields such as physics, economics, biology, chemistry, demography, and other sciences. So, there we go. So, what mathematical skills are needed in order to solve a derivative problem correctly and more efficiently? In solving derivatives, you need to have a good background knowledge about algebra and trigonometry. It is because these two will take you a few steps closer in solving the problem correctly and more efficiently. So, the main question is, why do we need to study derivatives? So, in a world of change, we must be conscious about the changes happening, and we need to study derivatives so because it somehow helps us to be one step ahead of change by making us knowledgeable on how to compute for the change happening. So, so in the problem, we were asked how long can a male born at the beginning of 2000s expect to live. So, we all know that the function is given, but we renamed we renamed the function as this new function. But don't worry because it's just the same. Because there's a principle, or I don't know what you call it, that x raised to 0.1 is just equal to 1 over x raised to negative 0.1. Meaning, whatever you put in the denominator, you will just change the sign of the power. So, knowing that this function is the same as the one given in the problem, we can now work with this equation. So, multiplying this value to the quantity, we will get this final or working equation, which is 46.9 all over the quantity 1 plus 1.090 raised to negative 1 all over 10. As you can see, we have wait, a u, sorry for the handwriting, and the v. And as if we all know that u and the v can be used in the quotient rule, which is v multiplied by the derivative of u with respect to derivative of x minus u multiplied by the derivative of v with respect to x all over v squared. So, we know that we have assigned 46.9 as the v and the quantity, this quantity as the v. So, we will just substitute this values to the representation. So, as the v, we will just substitute this one. So, derivative of v. So, we know that the constant rule, the derivative constant rule states that if there is a constant, you will just get 0 as its derivative. So, derivative of u, which is 0, minus u, which is 46.9, multiplied by the derivative of v, which is, in this case, we will use the power rule. So, you will multiply whatever power you have to the equation, which is negative to the quantity 1 plus 1.090 raised to the power minus 1. So, the power, which is negative 1 over 10 minus 1 is equal to negative 11 over 10. So, there you go. Now, with the denominator, we said that the denominator must be equal to v squared. So, what is our v? This is our v. So, if you substitute this value to this equation, you will get 1 plus 1.090 raised to negative 1 over 10 raised to 2. So, working the equation out, so you will just cancel this one because it is multiplied to 0, and anything multiplied to 0 is 0. So, you will get negative 46.9 multiplied by the quantity negative 1 over 10 times 1 plus 1.090 raised to negative 11 over 10. So, and as you can see, this is the, as we can say, the working derivative equation. So, we will use this to find out the rate, take note, the rate of change of the life expectancy. So, it is said that beginning of 2000, and we started with 1900s as 0, meaning you will get t as 100. So, substituting t, which is 100, to the working equation, we will get this function, which is, if you evaluate it, you will get 0.06822121127, or approximately 0.07 year per year increase in the lifespan of that male in that specific country. So, as you can see, this is the rate of change to which the lifespan of the male in that country increases. So, now we know the rate of change per year in the lifespan or life expectancy of males in that country. Now, we saw for how long can the male expect to live during if he is born in the beginning, or 100 as t. So you will substitute t to the first equation, which is this one. So we will be able to find out what is the current life expectancy of the male during the beginning of 2000. So, substituting 100 to this equation, we will get 75.04 years. So, we can say that males can expect to live for about 75 years old if they were born in the beginning of 2000, and they can expect the rate of change of 0.07 year per year as the time goes. And there you go, that is how